This is the second type of proof by induction, the divisibility type. So step 1, 2, and 3 remain the same. So step 1 is prove that it's true for n equal to 1. So we're going to take 8 to the power of 1 minus 1, which is 8 minus 1, which is equal to 7. And 7 is divisible by 7. Therefore, it's true for n equal to 1. Okay, so then step 2 is your assumption. So you assume it's true for n equal to k. So that means a to the power of k minus 1 is a multiple of 7. That's our assumption. Now we're going to prove that it's true for n equal to k plus 1. So replace k with k plus 1, so it's 8 to the k plus 1 minus 1, and we have to try and prove that that is divisible by 7, so that it is a multiple of 7. Okay, so we're just going to kind of work on the left hand side here a little bit. So using indice laws, this plus came from a multiplication, so it's 8 to the k times 8 to the 1 minus 1, which is 8 times 8 to the k minus 1. Now for these questions, you go back to the assumption and you manipulate it. So I'm going to take this 1 and bring it across, so you get 8 to the k equals 7m plus 1. I'm going to use that down here, so I'm going to replace the 8 to the k with 7m plus 1. So that gets replaced with that based on our sort of manipulated assumption. Yeah? So multiply it out, so that's 56m plus 8, and then you still have your minus 1, which is 56m plus 7. So I can take 7 out as a common factor, which leaves me with 8m plus 1. And essentially we have this thing multiplied by 7, which means we have a multiple of 7, which means it's divisible by 7. And then you finish off with your 3 lines at the end of induction. So we've proved it for n equal to 1. If it's true for n equal to k, then it has to be true for, if it's true for n equal to k, then it's true for n equal to k plus 1. So it's true for all n, it's an element of n. So your lines at the end that you have to write in.